Okay, we're going to be talking about cubic equations. I'm also going to extend this to one example which isn't a cubic equation, a quintic polynomial. That's going to be fifth degree. X to the fifth, blah, blah, blah. Okay? The rational root theorem. So here we are on cubic equations. You guys can read how that works. Okay? You should know about how synthetic division works, synthetic substitution works, before you study this. Okay, so this is the rational root theorem, rational zero theorem. Roots and zeros for polynomials are the same thing. So stay on this page because we're going to be using these steps. I'm not going to do any of the examples on the other pages. Okay? So, you've probably solved equations by cubic equations by something called factoring by grouping. The problems that I'm showing here on the board, these cubic polynomials are not factorable by grouping. Okay? To factor by grouping, you need 4 terms. This one only has 3. For this one, if you factor an x squared out of these 2 terms, that would be x plus 3. You're not going to get x plus 3 out of that. If you factor an x squared out of here, you'll get x minus 5. If you factored a 2 here, you'd get 8x plus 11. Okay? The binomials have to match, and they wouldn't. Okay? So, we're going to have to use the rational root there. So, we're working on this one. Find. So this is where we're at. That one right now. This is the one we're at. Okay? So to find the roots or zeros of 2x cubed minus 61x plus 55, we need to solve 2x cubed minus 61x plus 55 equals 0. Okay, as I said, it's not factorable by grouping because it only has 3 terms. So what we're going to have to do is we're going to have to use the P over Q stuff that's on the top of this table, that's on the top of cubic equations, page 2. All right. Now, P is going to be all my factors of 55. Okay? So the factors of 55 are factors of 55, factors of the constant. So that would be plus or minus 1, plus or minus 5, plus or minus 11, plus or minus 55. Those are the factors of 55. Okay? Q are the factors of 2. So that would be plus or minus 1, plus or minus 2. Okay? P is my factors of the constant. Q is my factors of the lead coefficient. The minus 61 doesn't matter. Okay? So plus or minus P over Q would be, well, 1 over 1 plus or minus 1 over 1, 5 over 1, 11 over 1, and 55 over 1. Okay? That's half of them. The other ones would be 1 over the 2, so 1 over 2, plus or minus 5 over 2, plus or minus 11 over 2, and plus or minus 55 over 2. Okay, so 1 divided by 1 is 1, 5 divided by 5 is 5, 11 divided by 1 is 11, 55 over 1 is 55. and it's going to be these four. 1/2 plus or minus 1/2 plus or minus 5/2 plus or minus 11/2 plus or minus 55/2. So put another way, plus or minus P over Q equals all the P's. It also equals 1 over 2 plus or minus 5 over 2 plus or minus 11 over 2 plus or minus 55 over 2. Okay, so possible rational roots. Plus or minus, positive or negative 1, positive or negative 5, positive or negative 11, positive or negative 55. Positive or negative 1 over 2. Okay, I'm just taking all of these and putting them over here for convenient reference. Okay, so the potential rational roots, these are the solutions that could be written in fraction form, are listed there. Okay, possible rational roots. Okay, now, so step 1 has been done. List the potential rational roots. Step 2, check them into the polynomial using synthetic substitution. I recommend starting with 1. If the result is 0, you have a root. If the result is not 0, you never need to consider that root again, that potential root again. So, check them. We want 0. We want 0. Okay? So, if f of x is 2x cubed plus 0x squared minus 61x plus 55, notice I put a 0 in for the x to account for the x cubed and x. So I will try x equals positive 1 first. 2, 0, negative 61, 55. You follow the synthetic division procedure for this part. Okay? But you use the actual number. So bring down the 2. 2 times 1 is 2. Add them up, you get 2. 1 times 2 is 2. That's negative 59. One times negative 59 is negative 59. That's negative 4, which is not 0. Okay, so x does not equal 1. Okay? So 1 failed. Now I would try negative 1. 2, 0, negative 61, 55. So 1 failed, now I will try negative 1. So bring down the 2. Negative 1 times 2 is negative 2. Add them up, you get negative 2. Negative 1 times negative 2 is positive 2. I get negative 59 again. Negative 1 times negative 59 is positive 59. That's 114, which is not 0, so x does not equal negative 1. Okay? So 1 failed. Negative 1 failed. Now we'll try positive 5. Okay? Two, 0, negative 61, and 55. Okay? Bring down the 2. Bring down 2. 2 times 5 is 10. 0 plus 10 is 10. 5 times 10 is 50. Add them up, you get negative 11. 5 times negative 11 is negative 55. That's 0. That's what you want. Okay? So, that means that x equals 5. Okay? X equals 5. All right, now that we've got a root, let's look at the next thing we would do. Step 3. When you get a proposed root which results in 0, you have a root. You will list it at the end. Okay? The next step. For other numbers on the bottom row, make a new polynomial equation starting 1 power lower. Okay? So you got to remember, this is not only synthetic substitution, it's also synthetic division. This is a division result. So I have, since it started with x cubed, I will have 2x squared plus 10x the first minus 11. Okay? You will want to set the quotient equal to 0 as well and solve it by whatever methods you can. Okay? This is not easily factorable. Okay? Not easily factorable. Reason, it's a trinomial. The lead coefficient is not 2. It's not 1. It's 2. And 2 doesn't divide all 3 terms. So I would use the quadratic formula. Okay? So, A equals 2, B equals 10, C equals negative 11. Okay? And x equals negative b plus or minus b squared minus 4ac all over 2a. So for this problem, x equals negative 10 plus or minus 10 squared minus 4 times 2 times negative 11 all over 2 times 2. Okay? So, first, under the radical. So that's 10 squared minus 4 times 2 times negative 11. 100, there's 2 minuses, so that's a plus, and that's 88. So that's 188. Second, the square root of 188. We'll have to simplify that radical. It's divisible by 4. Perfect square 4. 188 divided by 4 is 47. So that's 2 square root of 7. Third, x equals negative 10 plus or minus, I'm sorry, that should be 47. 2 square root of 47 over 4. All 3 terms are divisible by 2. All terms divisible by 2. So we will do it. Okay? Last, x equals 5, and all 3 of these are divisible by 2, so negative 5 plus or minus a single square root of 47 all over 2. Okay? And that's 3 solutions. It's a cubic, so there's a potential for 3 solutions. They are 5, that's 1, negative 5 plus square root of 47 over 2, that's 2, and negative 5 minus the square root of 47 over 2. That's 3. Okay? And this one is done. So this is the one that we're at. This next one. I'm going to put the quadratic formula up here for convenience. Okay? So now, this is the one that we're working on. F of x equals x cubed plus 3x squared minus 73x plus 165. So that means we will solve x cubed plus 3x squared minus 73x plus 165 equals 0. P is all my factors of 165. They are 1, because 1 divides anything. 165 is odd, so 2 doesn't divide it, nor does any other even number. Okay? 165 divided by, let's try 3. 165 divided by 3, that's 3. Okay? It divides evenly. That's 55. I'm not going to write the 55 down yet. Okay? We're going to work our way up and then work our way down. Okay? It's not going to be 4 because it's not even. The last digit is 5, so we know 5 divides it. It's not even, so 6 doesn't divide it. 7, 165 divided by 7 is a decimal. Okay, so doing 7 doesn't work. 160, well, it's even, so 8 doesn't. Sorry, it's odd, so 8 won't do it. Let's try 9. I get 18 1/3, so 9 doesn't work. 10, the last digit isn't 10, it's odd, and 10's even, so it won't divide. 165 divided by 11, that's 15. Okay, 14 doesn't divide it. 12 won't divide it, because again, it's odd. So, and odds aren't divisible by evens. 165 divided by 13. A weird look decimal, that won't work. 14 doesn't work. And 15 does, and it gives me the 11 when I divide by 15. So now I will work my way down. 165 divided by 5 is 33. 165 divided by 3 is 55. And 165 divided by 1 is itself. Okay? Q is plus or minus 1. The factors of the lead coefficient. So plus or minus P over Q equals plus or minus 1 over 1, 3 over 1, 5 over 1, 11 over 1, all plus minuses, but the fact is division by 1 changes nothing. So it ends up just being all the P's. Okay? Try them. In f of x equals x cubed plus 3x squared minus 73x plus 165. And we want to get 0. That's the goal here. So we will start with, I start with 1. If that fails, I try negative 1. Then I try 3. If that fails, I try negative 3. And so on. So I'll try x equals 1. I got 1, 3, negative 73, and 165. Okay? So, bring down the 1, that 1. 1 times 1 is 1, that's 4. 1 times 4 is 4, that's negative 69. 1 times negative 69 is 96, which is not 0, so x does not equal 1. Okay? So, 1 failed, now I will try negative 1. So it's 1, 3, negative 73, and 165. And again, I want 0. So, bring down this 1. 1 times negative 1 is negative 1. That's 2. Negative 1 times 2 is negative 2. That's negative 75. When you add them, negative 75 times negative 1 is positive 75. That is 240, which is not 0. So x does not equal negative 1. Okay? So, 1 failed, negative 1 failed, 3 is the next candidate. So, it's 1, 3, negative 73, and 165. And bring down the 1. 1 times 3 is 3. That's 6. 3 times 6 is 18. Add these up, you'll get negative 55. 3 times negative 55 is negative 165. That's 0. And that's what we want. So that confirms that x equals 3. We will need to remember to write that when we're done. Okay? Also, this was also a division result. So that's a quotient. So x squared, 1x squared, plus 6x minus 55, and I need to set it equal to 0. Okay? I want to see if it's easily factorable. It's a trinomial. The coefficient is 1, so that's a good sign. And I could come up with 2 factors of negative 55 that are divisible, that add up to 6. So this is factorable. Okay? I got x and x. 2 factors of negative 55 that have to positive 6 are positive 11 and negative 5. So, x plus 11 equals 0. X minus 5 equals 0. So subtract your 11. X equals negative 11. Add your 5. X equals 5. So the zeros are x equals negative 11, 3, and 5. This could have been factored as x minus 3, x plus 11, x minus 5. Okay? So we are done with this one, and we're at that one. So now we want to solve x cubed minus 5x squared plus 16x plus 22 equals 0. Again, it's not factorable by grouping. So we're going to have to do this using the rational root theorem, or rational zero theorem. So P is all my factors of 22. That's 1, 2, 11, and 22. Q is all my factors of the lead coefficient 1. So plus or minus P over Q is all the P's. Since 1 divided by 1 is 1, 2 divided by 1 is 2, well, plus or minus 1 divided by 1 is plus or minus 1, plus or minus 2 divided by 1 is plus or minus 2, and so on. Okay? Division by 1 doesn't change anything. Okay, so try them in f of x equals x cubed minus 5x squared plus 16x plus 22, and I want 0. We want 0. Okay? So I will start with 1. And that's going to be 1, negative 5, 16, and 22. So bring down this 1. 1 times 1 is 1. That's negative 4. 1 times negative 4 is negative 4. That's 12. 1 times 12 is 12. That's 34, which is not 0, so x does not equal 1. So 1 failed. Now I will try negative 1. Okay, 1, negative 5, 16, and 22. Okay, bring down the 1. Negative 1 times 1 is negative 1. That's negative 6. Well, I want to make sure I copied this down right. Okay, it is copied down right. So let's resume. Okay? So we tried 1, it failed. Now we'll try negative 1. So bring down this 1. Negative 1 times 1 is negative 1. That's negative 6. Negative 6 times negative 1 is positive 6. That's 22. Negative 1 times 22 is negative 22. That's 0. That's what we want. X does indeed equal negative 1. Okay? Now, this is also a quotient. So that's x squared minus 6x plus 22 equals 0. Ideally, I'm going to solve it by factoring. So it's in good shape for now. Well, the fact that the coefficient is x is 1 is good. The problem is I cannot come up with 2 factors of 22 that have to negative 6. So it's not factorable. So I'll use the quadratic formula. Okay? A is 1. B is negative 6, C is 22. So x equals negative b, so that's negative 6, plus or minus the square root of b is negative 6 squared minus 4 times 1 times c, which is 22 in this case, all over 2 times the 1. first under the radical. So negative 6 squared minus 4 times 1 times 22. So that is 36 minus 88, which is negative 52. Okay? Second, the square root of negative 52, well, it's a square root of a negative number, so we're going to factor out the imaginary unit, and that gives me the square root of positive 52. 52 is divisible by the perfect square, 4. 52 divided by 4 is 13. Okay? So this ends up being 2 times I times the square root of 13. Third, we deal with the larger expression. Positive 6 plus or minus, that is 2i square root of 13 over 2 times 1 is 2. Last, x equals the negative 1 we just got, and both of these are divisible by 2. So 3 plus or minus I square root of 13. Okay? So, we're done with this one, and here is where we are at. Okay? I'm going to do the quintic polynomial. I have a copy of it off screen. F of x equals x to the fifth minus 4x to the fourth minus 8x cubed plus 42x squared minus 9x minus 54. So this means we will solve x to the fifth minus 4x to the fourth minus 8x cubed plus 42x squared minus 9x minus 54 equals 0. Okay? Okay, the first time I attempted to do this, a quintic polynomial, it didn't fit on I thought it was showing parts of the board that it wasn't. So I'm redoing this about a year later. So actually about a semester later. So here goes. The previous version of the problem was this. It was on the agenda, which has been erased to make room. So I've got f of x equals x to the fifth minus 4x to the fourth minus 8x cubed plus 42x squared minus 9x minus 54. To solve this, we just need to set it equal to 0. We need to take this, set it equal to 0. It's a quintic polynomial. It's a fifth degree. So the only method available for this is the P and Q method. P is all my factors of 54. So that would be 1, 2, plus or minus 3, plus or minus 6, plus or minus 9. That's a matching pair. So 54 divided by 3 is 18. 54 divided by 2 is 27. And by 1 is itself. Q is all my factors of the lead coefficient 1. So plus or minus P over Q is just all the P's. Okay? Now, so we'll try x equals 1. Remember, we're going for 0. We want 0 to be at the end of the synthetic substitution process. Negative 4, negative 8, 42, negative 9, negative 54. So, here's a box. I'll try to bring down the 1. 1 times 1 is 1. That's negative 3. 1 times negative 3 is negative 3. That's negative 11. 1 times negative 11 is negative 11. That's 31. 1 times 31 is 31. That's 22. And then 1 times 22 is 22, which is negative 32, which is not 0. Okay? So x does not equal 1. Now we'll try negative 1. So 1, negative 4, negative 8, 42, negative 9, negative 54. Okay? 1 times negative 1 is negative 1, that's negative 5. Negative 1 times negative 5 is positive 5, that's negative 3. Negative 1 times negative 3 is positive 3, that's 45. 45 times negative 1 is negative 45, that's negative 54. Negative 54 times negative 1 is positive 54, that's 0, so x equals negative 1. Okay? So what we now have is we have x to the 4th minus 5x cubed minus 3x squared plus 45x minus 54. It equals 0, and we're going to repeat the process. Okay? So we'll try negative 1. 1 is out. Once 1 is out, it's out for good. Any time a root is out, it's out for good. So, but 1 is a possibility. Negative 1 is a possibility again. So, negative 1 goes in the box. We got 1, negative 5, negative 3, 45, and negative 54. Okay, bring down the 1. 1 times negative, oops, negative 1. So bring down the 1 times negative 1 is negative 1, that's negative 6. Negative 1 times negative 6 is 6, that's 3. Negative 1 times 3 is negative 3, it's 42. Negative 1 times 42 is negative 42, which gives me negative 96. So not this time. Not this time. So 1 is out, it failed the first time. 1 was a root once, but it failed the second time, so now 2 is the only candidate. Okay, now the next candidate will be 2. So we'll try x equals 2. So we got 2, and we're going to use this polynomial, the quotient from the, so 1, negative 5, negative 3, 45, negative 54. So here's the continuation. So got my box, bring down the 1. 1 times 2 is 2. That's negative 3. 2 times negative 3 is negative 6. That's negative 9. 2 times negative 9 is negative 18. That's going to be 27. And 2 times 27 is 54. That's 0. So x equals 2. Okay? And we have x cubed minus 3x squared minus 9x plus 27 equals 0. It's a cubic, so I check to see whether or not it's factorable by grouping. So this is negative 3 times this. This would be negative 3 times that. So if I factored out an x squared here, I would get x minus 3. If I factor out a negative 9, I would again get x minus 3. So I'm going to try factoring by grouping. So I'll take the x squared out. We have x minus 3 minus 9 times x minus 3 equals 0. So I got x squared minus 9 times x minus 3 equals 0. That also is factorable by grouping. X plus 3, x minus 3 times x minus 3 equals 0. Okay? So x plus 3 equals 0. This has got to be x minus 3 multiplicity 2. Okay? So, subtract 3, x equals negative 3. Add 3, x equals 3, multiplicity 2. So, the final result is, in order from least to greatest, x equals negative 3, negative 1, 2, and 3 multiplicity 2. So that's what a fifth degree polynomial looks like. Okay? And I went ahead and decided to do another example. Okay? This is x to the fifth plus 9x to the fourth minus 18x cubed minus 141x squared plus 251x plus 30. Okay? Let's see if I can zoom in a little closer. All right, so P is all my factors of 30. So plus or minus 1, plus or minus 2, because it's even, plus or minus 3, plus or minus 5, plus or minus 6. That's a matching pair, so all I have to do is divide down. 30 divided by 3 is 10. 30 divided by 2 is 15. And 30 divided by 1 is itself. Q is plus or minus 1. All the factors of the lead coefficient. So plus or minus P over Q is all the P's. So we'll try x equals 1. So I got 1. I got 1, 9, negative 18, negative 141, 251, and 30. Okay, bring down the 1. 1 times 1 is 1. That's 10. 1 times 10 is 10. That's negative 8. 1 times negative 8 is negative 8. That's going to be negative 149. 1 times negative 149 is negative 149. That's 102. 1 times 102 is 102. So that's 152, which is not 0. X does not equal 1. Now let's try x equals negative 1. So we got negative 1, 1, 9, negative 18, negative 141, 251, and 30. Okay, I'm going to repeat the process. So that brings me down my 1. 1 times negative 1 is negative 1. That's 8. Negative 1 times 8 is negative 8. That's negative 26. Negative 1 times negative 26 is positive 26. That's negative 115. Negative 1 times negative 115 is 115, and that is 366. Negative 1 times 366 is negative 366. That's negative 336, which is not 0. So x does not equal negative 1. So now we'll try 2. 1, 9, negative 18, negative 141, 251, and 30. Okay, bring down the 1. 1 times 2 is 2, that's 11. 2 times 11 is 22, that's 4. 2 times 4 is 8, that's a negative 133. 2 times negative 133 is negative 266, that's negative 15. And 2 times negative 15 is negative 30, that's 0. So x equals 2. We also have a quotient. X to the fourth plus 11x cubed plus 4x minus 1 squared minus 133x minus 15. That needs to be solved for 0. So if we have x to the fourth plus 11x squared, or x cubed, plus 4x squared minus 133x minus 15 equals 0. Now, notice that the constant has changed. Okay? So, unlike the previous example, we can actually reconsider what P is. P's and Q's. Okay? So, P is all my potential factors of 15. They are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Q is plus or minus 1, so plus or minus P over Q is all the P's. Okay? These P's. Okay? So 2 is out. Okay? I wouldn't try 2 again this time. I would go straight to, because if you guys know, remember, 1 was eliminated, negative 1 was eliminated, and, well, we would normally try 2 again, but 2 is not a factor of negative 15. So we'll skip on to the next one. So 1's out, negative 1 is out. So 1's out, negative 1 is out, 3 is next. So 1, 11, 4, negative 133, and negative 15. Okay? So again, x does not equal, or well, I rephrase it this way. 1, negative 1 are out. Okay? They're out. So, bring down the 1. 3 times 1 is 3. That's 14. 3 times 14 is 42. That is 46. 3 times 46 is 138. That's 5. 3 times 5 is 15. That's 0. So x equals 3. Okay? So now we have x cubed plus or minus 14x squared plus 46x plus 5 equals 0. Okay? It's not factorable by grouping. How can I tell? If I factor x squared out of this, I get x plus 14. I'm not going to be getting x plus 14 out of that. Okay? So it's not factorable by grouping. Not factorable by grouping. So we're going to have to mind our P's and Q's again. P is all my factors of 5. 1 and 5, sorry. All my factors of 1 and 5. Okay, Q, lead cofactors of the lead coefficient 1. So plus or minus P over Q is all the P's. But again, 1 and negative 1 are out. Okay? So 1 is out, negative 1 is out, so now we'll go to 5. So I got 1, 14, 46, and 5. So bring down the 1. 5 times 1 is 5. That's 19. 5 times 19 is 95. That is 141. 5 times 141 is 705, which is 710, which is not 0. So 1's out, negative 1's out, 5 is now out. Okay? X does not equal 5. Now try negative 5. Okay? So I got 1, 14, 46, and 5. Bring down the 1. Negative 5 times 1 is negative 5. That gives me 9. Positive 9. 9 times negative 5 is negative 45. That's 1. Negative 5 times 1 is negative 5. That's 0. So x equals negative 5, and I have x squared plus 9x plus 1 equals 0. Not factorable. Okay? Because I can't come, there's no fair pair of factors of 1 that add up to 9. Okay? So we'll use the quadratic formula. So x equals negative b plus or minus b squared minus 4ac all over 2a. And x equals, or a equals 1, b is 9, c is 1. So x equals negative 9 plus or minus 9 squared minus 4 times 1 times 1 over 2 times 1. So first, the radical. 9 squared minus 4 times 1 is 81 minus 4, which is 77. Second, square root of 77 is irreducible. There are no perfect squares that divide 77. Okay? So very simply, because we're getting down to it, x equals negative 5. That's the lowest, I believe. 2, 3, and negative 9 plus or minus the square root of 77 over 2. And it's a fifth degree polynomial. There are 5 solutions. 1, 2, 3, plus is 1, minus is another. 5 solutions here. All right, I'm back in a classroom at Franklin. If I want to find all zeros of this polynomial, what I would do is I would set the polynomial equal to 0. Now you may have done quartics before, where you let u equal x squared, but that only method and substituted. That method only works if you have even powers of x. We have odd powers of x, so that method wouldn't have worked even if you knew what I was talking about. So what we're going to have to do is we're going to have to use the p over q method. So p is all my factors of the constant. 1, 2, because 26 is even, 13, and 26. Q is all my factors of the lead coefficient 1. So plus or minus p over q, all these over 1 would just leave these unchanged. So it's all the p's. All right? So we'll start with x equals 1. Try x equals 1. Try x equals 1. So I put 1 in the synthetic substitution box. 1, negative 9, negative 47, negative 63, negative 26. And I'm looking for 0 right there. Okay? So I bring down the 1. 1 times 1 is 1. That's negative 8. 1 times negative 8 is negative 8. That is negative 55. 1 times negative 55 is negative 55, and that is going to be negative 118. And then times another 118 is going to give me negative 144, which is not 0. Okay, so x does not equal 1. Okay, next I'll try x equals negative 1. So I got negative 1 in the box, 1, negative 9, negative 47, negative 63, and negative 26. Bring down the 1. 1 times negative 1 is negative 1, that's negative 10. Negative 1 times negative 10 is positive 10. That's negative 37. Negative 1 times negative 37 is positive 37. That's negative 26. Negative 1 times negative 26 is positive 26. That's 0. Okay? So x equals negative 1. Okay? And then this brings me x cubed minus 10x squared minus 37x minus 26 equals 0. It's a cubic polynomial, so ideally we want to see if it's factorable by grouping. Allow me to adjust this down a little bit. All right, so it's not factorable. I want to see if it's factorable by grouping. Well, this is negative 10 times that. This is not negative 10 times that. Okay? If we took an x squared out of these two terms, we'd get an x minus 10. You're not getting an x minus 10 out of that. So it's not factorable by grouping. So we'll have to mind our P's and Q's again. Plus minus P over Q equals all the previous P's because we still have 26. So it'd be all the factors of, let's see, let's do this again. So let's see, P, all my factors are 26. So plus or minus 1, plus or minus 2, plus or minus 13, plus or minus 26. Q, plus or minus 1. So all the factors lead coefficient 1. So plus or minus P over Q equals all the P's with one exception. 1 is out. Okay, 1 is out. Okay, so we have x cubed minus 10x squared minus 37x minus 26 equals 0. Try x equals negative 1 again. So I'll try negative 1 again. Okay, we already did it again. I'll try it over here for the new one. We have 1, negative 10, negative 37, negative 26. That's negative 1. We're trying negative 1 again. All right, so I bring down the 1. Negative 1 times 1 is negative 1. That's negative 11. Negative 1 times negative 11 is positive 11. That's negative 26. Negative 1 times negative 26 is positive 26. That's 0. So we got 0 again. So x equals negative 1 again. Okay? It equaled it once before. And it equals, it happened again. Okay? So, now we have a power, this was an x cubed, this was x cubed, so this is 1x squared minus 11x minus 26 equals 0. I want to see if it's potentially factorable. Okay? So, I'm looking for the x squared is, I want to see if it's easily factorable. Coefficient is 1, that's a good sign. And then I'm looking for two factors in negative 26 to add to negative 11. That's negative 13 and positive 2. So, we have x minus 13, so it's factorable. So it's x minus 13, x plus 2 equals 0. Okay, so I'll set x minus 13 equal to 0, x plus 2 equals 0. Add 13, x equals 13. Subtract 2, x equals negative 2. So all the solutions in order from least to greatest are x equals negative 2, negative 1 multiplicity 2, and 13. All right. And that's it. And here's a final example. Okay? What this means to do is to solve 9x cubed plus 8x squared minus 19x plus 2 equals 0. It's a cubic, so we consider factoring by grouping, but it can't be done. If you take an x squared out of here, you get 9x plus 8. You're not going to be getting 9x plus 8 out of that. So not factorable by grouping. Okay? So, P was all my factors of 2, so plus or minus 1, plus or minus 2. Q, all my factors of 9, plus or minus 1, plus or minus 3, plus or minus 9. So plus or minus P over Q is all the P's and 1 plus or minus 1/3, 1 over 3, plus or minus 2 over 3. And 1 over 9 and 2 over 9. Okay? So, we'll try x equals 1. So we'll start with 1, just all the p's. 1, then negative 1, 2, then negative 2. So we'll start with 1. We got 9, 8, negative 19, and 2. Rain down. Let me make that 9 a little bit neater. Bring down the 9. 1 times 9 is 9. That's 17. 1 times 17 is 17. That's negative 2. 1 times negative 2 is negative 2. That's 0. Okay? So x equals 1. We also have 9x squared plus 17x minus 2 equals 0. Not easily, the Lie coefficient is 9, and it can't be factored out of all three terms. So this is not easily factorable. Now maybe it is factorable. It's just not easily factorable. So we'll use the quadratic formula. Okay? So according to this, A is 9, B is 17, and C is negative 2. A, B, C. Okay, include the signs. So, x equals negative 17 plus or minus the square root of 17 squared minus 4 times 9 times negative 2 all over 2 times 9. Okay? First, under the radical. So I got 17 squared minus 4 times 9 times negative 2. That is 289 plus. Okay, because there's two minuses, you'll actually be plussing. Okay? So negative 4 times 9 times negative 2 plus 72 gives me 361. Second, square root of 361 is 19. So, we actually have a radical we need to simplify. X equals, we have a larger expression to simplify. So negative 17 plus or minus 19 over 18. Okay? There's no I, there's no radical. These can be added and subtracted because they're like terms. So it's negative 17 minus 19 over 18, or negative 17 plus 19 over 18. So that is negative 36 over 18. That is negative 2. This is going to be 2/18, which is 1 ninth. So in order from least to greatest, the zeros are x equals -2, 1/9, and 1.